Hello, everybody. I'm getting really close to where I can start seeing the benefits of all the hard work I've been putting on my 3D animation system, animating meshes. So I'm really hoping today, fingers crossed, that I can at least see some mesh animating across my thing here. So right now I just got the one stationary mesh, still static, but really hoping I can get it moving today. So I don't need that. What I'm gonna do, I'm gonna disable all of this just so I can really only see the mesh, the animated mesh. And let's see. So where did I leave off? That's a good question. Yeah, so I was doing this update mesh animation. Still not quite sure how I'm gonna do that, but what I'm gonna do in the interim is make a new function. I'm gonna call it render animated mesh, and for right now it's just going to take one mesh and animate it, or at least put it in the proper pose. And it's kind of misleading because it's not really going to render it, it's just going to push a textured mesh to the already existing textured mesh renderer. But anyway, it's just to hopefully get it working for now. And then so I need a position to put it. I need a size to scale it, and then I need a quaternion to know how the orientation is. Okay, so for now it's just going to add a textured mesh to the buffer, passing in the game state. I need the address of the mesh is mesh. So then it's just going to pass in position, scale, and orientation. Okay, so down here where I am calling it, or I'm adding the mesh to the buffer, so I'm going to stop doing that and just use that function I just made. So render animated mesh, that's what I wanted. All right, so I'm going to pass in the address of tentacle. Oh, by the way, where'd it go? Okay, so here I'm creating tentacle. I'm not assigning it an animation, so I need to do that. So that's the address of mesh animation. And so now, where did I leave off? Down here. Oh yeah, so I'm rendering tentacle, and then all of this stuff is going to be the same. Okay, so now if I run it, then it should stay, yeah, so nothing's changed, which is what I wanted. So now when I am rendering an animated mesh, I actually need to change the vertices. I need to change the vertices that I'm rendering to be in the pose that I'm trying to animate it in for that current frame. So with that being said, I need to actually change my textured mesh renderer. I need to set it up slightly differently, and come to think of it, I need to change the way I'm actually creating the textured meshes. Yeah, so here where I'm making my vertex buffer descriptor, I need to set it up a little bit extra. So I need to set the CPU access flags to be CPU D3, D11, CPU access, CPU access writes. I want to be able to write to the buffer, and then I need to also change this usage to be D3, D11 usage dynamic. Okay. So that's going to be for the index buffer. But then when I'm doing it for the constant buffers, I got to set all this back. So that will be nothing, and that is default, whatever that is. Okay, so that shouldn't crash when I run it, but I shouldn't see my mesh anymore. That's correct. So now I need to change the way I create my textured meshes. That's down here. So this is no longer the way. Yeah, basically this update sub resource is no longer the way I'm going to do it. So I don't need those boxes either. So I'm going to get rid of all of those. Let me go ahead and move this to the top. And so I need to start mapping the buffer just like I'm doing here. Make sure I change this to be the correct renderer. All that should be good. And then I need to unmap them as well. Okay. All right, so then here I need to increase this by the total amount of indices, total indices. So that would be idat plus equals total indices. And then the vdat is going to increase by, I don't have a total vertices. Well, it's not really a total vertices, it's how many floats in the buffer already. So that is the textured mesh renderer dot vertex data used divided by whatever the size of a float is, and then that's that. So then I want to iterate through the vertex data and assign all of that data there. So let's do that. So that is the hold on. Yeah, so this is the vertex data size divided by the size of a float. I should actually pre-compute that. So this is, what is this? U32 total floats, something like that. Total floats. All right, so yeah, I'm just copying everything over from the vertex data over to vdat. So, all right, so that's that, and then do the same for idat and index data. Okay, that might be it. Let me go ahead and compile that, see if it does, and it doesn't. So that's because I'm missing semicolons. And dat should be idat. Dang it. Okay, so what am I missing? What am I doing wrong here? So that's total vertex data used. This doesn't have any effect. I'm doing this twice. That's weird. And this can go at the end. Okay, but that doesn't fix anything. That does not fix my problem. Nope. Should still see my mesh show up. This should be okay. No overwrite, I guess. Oh no, that's not, okay, so that shouldn't be total indices, that should be index offset. There we go. I hope that was the problem. Yay, all right, great, great, great. That is cool. So that is only one small step into this whole debacle. Oh man, okay. All right, so now here I have to actually start mapping that buffer. So let me try doing that. And I only need to do half. So I don't need to map the index data. Oh, yeah. So that should all be good there. And then I need to make sure I unmap it. All right, and then, so I got to increase this by the vertex offset, which reminds me, well, it doesn't really remind me, that's the wrong choice of words, but it makes me realize that I need to actually save that into a textured mesh. Yeah, I'm going to need to add that here. Let me do that. So, textured mesh. So now it needs to have the vertex buffer offset. And then it needs to know how many total vertices it has. So back here, the total vertices is total verts and buffer, same thing. And mesh, oh no, wait, that's the total verts. No, that's wrong, that's not right. That's just should be vertex data size. Actually, I could put back what I had. Oh, never mind. Sorry. Vertex data size divided by size of a float times 8. Okay, so now the what is it? Vertex buffer offset is equal to this. All right, so now VDAT has to plus equals the mesh dot vertex buffer offset. I need a lot more stuff. All right, but I don't think that should change anything. Of course not. So now what's the next step? Oh, you know what? I think I need to also, so I got the weights and the bones, but I actually need to retain the positions and the normals too. I didn't think about that. Yeah, I think so. I think that's the best way to go for now. Positions, till I decide otherwise. That's here. Okay, so this is kind of the same. So I'm going to call this P pointer and N pointer. And that is positions, normals. So then I've got to do this twice now. So then P pointer is equal to that. And then we want to increase P pointer. And then the same for N pointer. Okay, so that should retain the positions and the normals, and then that'll be used here when I render the animation. So I need to make a for loop here. It's going to iterate through all the vertices. So this is for 32 I is less than the, you know, let me go ahead and pull out the animation from there. So the mesh animation, I'll just call it anim, is equal to the meshes animation. And then, so this is going to be the anim's total bone, no, total, wait, no, this is the mesh. What am I talking about? Meshes total vertices. Okay, so for now, I'm just gonna take the vertices and copy them directly over. So let me see about this. Let me see. So I got a vector 3. I'll call this vpos for vertex position, and that is going to be equal to, I need to basically pull a vertex 3. No, it's not. That's incorrect. From the animation. So the animation dot position. No, it's the mesh. It's the mesh again. Mesh positions. So I want to cast, because that's just a big old array of floats. So I want to cast that to a vector 3 pointer. Can I do this? Can I? If I wrap this in parentheses, can I then index it? Okay, I don't even know if I can do this, but I'm just checking to see if that syntax is allowed. Norm laws. Don't have no norm laws here. All right, so let's see if I run this. Oh, I get a exception. Oh, you know what? Yeah, I forgot to allocate memory for the positions and the normals. That's not good. All right, so that should fix that. Going back to here. Okay, so the weights look normalized. That looks good. And then the bones here, if I step out, where did they go? Okay, yeah, that looks legit. So I think that syntax works. So this is okay. So yeah, then I was just going to copy them over directly to the VDAT. So I'm not worried about the weights and the bones right now. So I'm just going to say that VDAT 0 is equal to vpos.x. See, 1, 2. Then VDAT at 3 is equal to V norm dot x. Okay. And then I want to increase VDAT by 8 because I want to skip over the texture coordinates. Okay, so everything's still working. Everything's just getting copied directly over, but that means that the positions are getting saved correctly and that I'm extracting them adequately. So now I need to, now we need to actually calculate what the new position of each vertex is based on the position of the bone. So I need to do some stuff before all of this, actually. I need to get a bunch of matrices. So I'm going to make an array here. I'm going to make an array of matrices. matrix 4. I'm going to call this pose matrices. So this will be the actual pose that I'm multiplying each vertex by. I'll just make 32 for now. Now to calculate these, I need a parent matrix, and I need to keep, I'm going to basically build the parent matrix as I'm calculating these. So I need to keep track of those. So I need another array for those. I'm going to call that parent matrix. Okay, but the root bone, the very first bone that I'm calculating the position and the orientation for, does not have a parent. So I don't need to worry about the parent matrix for that. So let me just think about that one bone for now. There's just the root, and then the others might come a little easier. So I need to calculate the actual matrix for it, which is just like building a model matrix, right? So I need the rotation first. Call this B rot, bone rotation. And this is where I use that slurp function that I wrote here. So I wrote this one. I actually didn't write it. I copied it directly off Wikipedia. So hopefully it works. I don't know. And then I also did this one. Oh, I did it wrong, by the way. Shoot, I completely left out the T. Ooh, good catch there. That would have been disaster. Okay, so yeah, so now I'm going to use this. So the quaternion I'm passing in is the rotation of the bone, which I don't know yet, or I don't know which bone in the matrix. So, okay, so let me calculate some other stuff here. So I need a float to know, because when I call linear interpolation and the spherical linear interpolation, I have to pass in this T. So I'm going to calculate that T first, and that is calculated by taking the animation's current keyframe. No, that's not right. Current pose elapsed. So how much time has already elapsed in this pose? And I'm going to divide that by the animation's current pose time. So how much time that pose is supposed to take. And this down here, when I finish it, is going to make sure this never goes over 1 or less than 0. And I should actually initialize those here. In fact, I'm not initializing anything here. I completely left this incomplete. So I need to do everything here. So the current keyframe, when you first create an animation, is always 0. The next keyframe is always going to be 1. I need to set the total bones. I think that's just total bones. Total bones, yeah. And then I need to set the total poses. I think that's also just total poses. So then I also need to calculate something here. I need to calculate, I need to set the frame rate. I'm going to say every animation has a default frame rate of 24. It's not really frames per second, but 24. I don't know what you'd call it. I mean, it is frames per second, but the game's not running at 24 frames per second, so I don't know how you phrase that. So then, yeah, so now that I have the frame rate, I can calculate the current pose time. Current pose elapse is 0, so that is the whatever the animation's keyframes at 1 minus the keyframes at, no, not 2, 0, divided by the animation's keyframes. No, that's wrong. Not keyframes. Frame rate. Okay, so now that that's done, this should make more sense. So this will be some number between 0 and 1, some floating point value. And now I need to know, so the bones are just a big array. Mesh animation. Yeah, just a big array of bones. The poses are just an array of bones. So I need to figure out how to make a matrix from those. So I need to know what index I'm talking about, and that depends on what keyframe I'm in, and that depends on how many bones there are. So let me do this. Let me make a U32. I'll call this current frame index, and that is the animation's current keyframe times the total bones. And then I can get the next keyframe basically the exact same way. All right, so now that that's done, I can figure out where the rotation is coming from. So that is going to be in the animations, the poses. It's called poses. We're just worried about the first pose at the current frame index, and we want the orientation from that. We want the same thing for the next one, except for that's going to be the next frame index, and we're passing in dt. Okay, so that's the rotation for the root bone. Now the position, we call this bpos, is a linear interpolation of the animation's poses at current frame index dot position. And poses next frame index dot position, passing in delta time. There we go. Okay, so now I can actually calculate what the matrix is. So the matrix, I'll call this bmat, is a model matrix. I need to build a model matrix using the position, so bpos. There's no bone scaling, so everything's going to be scaled by 1, and the quaternion is brot. So matrix 4. Okay, so that is, I think that's basically the parent matrix right there. So the parent matrix at 0 is bmat, but the actual pose matrix at 1 is bmat, but times the animation's, wait, is it the animation? Oh, like, that's why. Okay, so equals bmat times anims, the inverse bind transforms at 0. That should also be 0. Okay, so that should be the pose matrix for the root matrix, or for the root bone, and then this should just be used, or this will be used later to calculate all of the child bones positions. I hope I got this order right. Pretty sure I do. Okay, so that's going to take care of the root. I'm going to now iterate through the rest of them. So I'm going to start I at 1. I is less than anim's total bones. And it's essentially the same thing, but I'm going to have to add one more step. Okay, so this is all going to be plus I. Okay, so then instead of 0, it's I. All right. Okay, so the parent matrix. No, okay. So this is the same, but I need to add one more step here. I need to say that the bone matrix is equal to the inverse bind transform. So this is the animations poses. Right. Okay, so then the index into the pose is the oh yeah, I think it's the same thing. Current frame index plus I. Oh no, okay, wait, I know what I'm doing now. So this is, I need to get the wait, yeah, dot. Hold on. Let me think about this for a second. Inverse, yeah, so the animation has the inverse bind transforms. So anims, inverse bind transforms, but the index of it is the parent matrix, and I get that by using the animations poses at the current frame index. I could use current frame or next frame in this case. Plus I dot parent index. There we go. Okay, and then I need to cast that to an integer. And I need to take all of that and multiply it by the by the bones matrix. Okay, I think that should do it. I have no idea if I'm right. But I built up a matrix, an array of matrices that is essentially the skeleton, the bones for that particular pose in that current animation keyframe. Okay, so all of that being said, I can now start building things. But to do that, I need to make a 4D vector. I'll call this npos. I'll call this P4. So it's a P4D vector. And this is vpos with 1. And this is and 4. Okay, so that's the same thing, but for the normals. And I don't think I inherent matrix undeclared identifier. Oh. 608. Parent matrix. There we go. Okay, yeah, I need to make a new constructor for my vector 4 so I can do it the fancy way. In fact, I gotta do a lot of stuff now that I think about it. My vector 4 is very incomplete. Okay, so that compiles. But yeah, I need to do a lot of stuff for my vector 4. I think I gotta do all of this, add, the subtract, the scale. Vector 4. Oops. And then it'll probably be faster to do this. Scale vector 4, 4, 4. Times amount. I feel like there's more to it. I gotta do more. Oh yeah, all these operators too. That should work. All right. Yeah, these two. This not. Yeah, so the negative operator and the minus operator has to be done too. That. B dot W. All right, how's that doing? Still got errors, so 199. Yep. Easy fix. I'm not worried about length and all that, but I do, shoot. Oh, you know, I need a multiply that will give me a vector 4. Multiply. Okay, so vector 4 R. Okay, so Rx is equal to the matrix is M2 0 0 times V dot X plus. Okay, so that's V dot Y. That's 1. Z2 W3. Okay, so that should do that. Let me go ahead and make an operator for that as well. For star, this is going to be a term multiply M and V. Okay. Does it compile? Yes, it compiles. Okay, so all of that being done, now I can get back to this and figure out how I'm going to get from here to here. Okay, so I got P4, which is VPOS, so now I need another vector 4. So I'll call this one NPOS, for new position. And so this is equal to the pose matrices, and the index is here inside the bones. So I'm going to say bones.x, and that's a flow, so I need to cast that to an int. So the pose matrices at that multiplied by P4. All right, and then that is going to be multiplied by the weight. So that's only 1, and so I need to do that 3 more times with the rest of the bones and the rest of the weights. And I have to do the same thing for the normals. Oh, I'm getting nervous. This is not going to work. So I'm going to call this NRM for the norm. That's that. This should be N4. Okay. So this should be, all of these actually should be N. Okay, does that do anything besides give me errors? I don't think so. To be EIGHT. I called it weights. Let's just fix that. Oh my goodness. It takes left-hand operator type vector 4. There is no except 633. What? Oh, I didn't do a operator for the scaling, I think. Yeah, that's the only one I did. You know, I'm going to put it on my to-do list. It's not really a thing, not really a big deal, but I want to get it done. I'm going to make another thing here for miscellaneous. Organize mathematics.h. So I just have things just all over the place. Okay, so that should fix that error, I believe. Scale, none of 3 overloads. Could. Am I putting this above the scale call? Oh, wait. No, that doesn't mean anything. Oh, wait, that's what it was. Okay, sure. Okay, whew. I got a broken mesh here. But hey, it's better than no mesh at all, so let's see if I can figure out why it's broken. So I checked these looked okay. I'm not 100% convinced that they are, but check that my math constructor v.w, v.x, v.y, v.z, so that should be fine. Here's a trick I can do. If I put all of these at identity matrix, that'll tell me if the problem is in the matrices. Okay, so then it just completely disappears. That makes me think that there is somewhere here. Hold on here. Okay, so if I just pass the position straight through, it's fine, but then the matrices are all messed up. So even when I do the pose matrices, even when I just set them all to the identity matrix, it's wrong. Why? Why? Huh, so it's weird. So I don't see it at all, but then if I put this back to what I thought it should be, then I see something. Just not what I would expect. So I feel like the logic is right. I just got a dumb typo somewhere. But it could also be this spherical linear interpolation is broken. Maybe it's not working as well as Wikipedia led me to believe, but I'm going to save that theory till later. Yeah, that's right as far as I can tell. Oh yeah, I got this. Should still be that one. Okay, so this is. Maybe I have this going backwards here. No. But yeah, so seeing as this, if I set this to just a regular identity matrix, and this one too. So it should just be normal. But then it completely disappears, like nowhere to be seen. So that means that I think the problem is somewhere here. Let me check plus equals operator. That's good. I'm very close, because if I just pass the data directly through, like if I skip all this, or undo all that basically, then the mesh is there. That's fine. It just has no animation, no pose applied to it. So it's something very simple. Something, it's like a typo. I feel like it. I feel it in my bones. I'm not seeing it. This doesn't make sense. So like this shouldn't really change anything. Because if this is all the identity matrix here, that should just all get set. Unless the weights aren't actually normalized, but they're close enough. I don't know. I think I'm going to take a 5 or 10-minute break, clear my head, maybe get some water, and then come back to this, and maybe I think it'll jump out at me. So let me do this here. All right, I am back. So when I left off, I have this thing here, but that should be not that thing. Should look like it's in a pose, but it's not. So let me go ahead and put this back here. See what the problem is. So yeah, it tells me the problem, like this looks right to me. So I think the problem is up here. Oh, you know what? I think I see it. Yeah, because I have the inverse bind transform here. I don't need to do the inverse bind transform here. I need to do the parent matrix. That's why the whole point I'm keeping track of this parent matrix is because that's what I need to use. I think that was my, whoops, I think that was my problem. All right, so now does it compile? Yes. All right, so that thing looks, I think it looks different. I don't even know. So that should be the parent matrix. Yeah, that's why that's called parent index, because that's the index into this parent matrix. But then it's still not right, so dang, that's a little frustrating. But at least I know that there are problems. All right, so now that that's done, let me go ahead and put this back to 0, put this back at the identity matrix. And it just completely disappears again. That's frustrating. So just out of curiosity, so that should be 0, but if I change this to be like 0.5, does that change, whoops, does that change the way it looks? Yeah, it does. So that it's definitely having some effect, albeit slightly. So something, it's like I got the multiplication wrong or a typo here on one of these things I was doing earlier. It's all good. Still holding out doubt that that's wrong, but that could still be a problem. mean, it seems like a reasonable position to be in. Why? Okay, so again, so if I set this back to 0 and just make everything in the pose matrices the identity matrix, that should set the problem, or that should make the mesh look like it's just standard without any animation, but it's not. So that, what does that tell me? It tells me the problem is here, actually. But it shouldn't be, because this looks, I don't see how it could be. I'm not seeing it. Hang on, I'll be right back. Okay, there's one more other thing I saw that was wrong. So this, I don't know if that's wrong. I mean, I don't know if it's definitely wrong, but I don't know if it's gonna fix the problem. But so vertex buffer offsets in bytes, right? But this is in floats. So I actually need to divide that by the size of the float. So that would definitely be one candidate, but it still doesn't fix my issue. But let's see. If I put this back to what it was. Yeah, still nothing. Still just a big jumble of polygons. So, oh gosh, this is frustrating. Because yeah, this should just be 0 anyway, I believe. Alright, so what is making this messed up? Yeah, I'm not seeing what it could be, so I don't know. I think I'm just tired. I need to wrap it up and try again next time. Got really close, really close, really, really close. I'll get it though. So whatever. Git, add everything, git, commit, m. Still no mesh animations. Push it. Okay, so hopefully next time we'll get it. I'm not losing hope yet. But thanks for sticking with me. I'll see you next time. Bye.